Hi folks, welcome back to Physics with Captain Rod. I'm making this video to help you out with numbers 6, 7, and 8 in your Unit 4 homework. So these are problems about Coulomb's law. So let me talk a little bit about Coulomb's law. Coulomb's law is the force between any two charged particles that carry a charge Q1 and Q2 is the force is equal to K times the product of the charges, Q1 times Q2, over the distance between them squared. The K is called the Coulomb constant. I like to round it to 9 times 10 to the 9th Newton meter squared per Coulomb squared. If you look in your textbook here, this will probably be written 8.99. Either one is acceptable. Again, there's it's right around 1% difference between the two. I just use 9 times 10 to the 9th because it's easy to remember and short to write. So number 6, it says, how strong is the attractive force between a glass rod that carries a 0.75 microcoulomb charge and a silk cloth with a negative 0.63 microcoulomb charge if they are 15 centimeters apart, approximating them like they act like point charges? So we have a glass rod. I'm just going to approximate it with a point charge. So that's going to be my Q1. Now 0.75 microcoulombs means 0.75 times 10 to the minus 6 coulombs. Then there's a silk cloth, negatively charged. So my second charge is minus 0.63. Now it says microcoulombs. That means 10 to the minus 6 coulombs. The distance between them is given in centimeters. Mine says 15 centimeters. That's 0.15 meters, writing it with what I would call standard physics units. So because one is positively charged and one is negatively charged, there's going to be an attractive force between them. Basically, they're going to pull on one another. And that force can be calculated using Coulomb's law, K, Q1, Q2 over distance squared. So for the Coulomb constant, you're putting this value. For charge 1, you're putting this value. For charge 2, you're putting this value. You notice I didn't include the minus sign. I'll explain why in just a minute. And for the distance here, you're putting this value, 0.15. The reason you don't need the minus sign in the calculation is I used the minus sign when I drew this as an attractive force. That's what the minus sign is for, is determining whether the force is attractive or repulsive. After that, when you're doing calculations, this is just some number. This is the magnitude of this force. So that should get you through A. Let's see, I think that was number 6. Okay, number 7. How far apart must 2 point charges be if they're 90 nanocoulombs to have an 8.1 Newton force between them? So we have a pair of point charges. And they're the same. Now in mine it says 90 nanocoulombs. Now nano means 10 to the negative 9th. And they're the same charge. So 90 times 10 to the minus 9th coulombs. What's the unknown here is the distance between them. The force between them, right, would be a repulsive force because they're both positively charged. And that force is given at 8.1 newtons. So you write out Coulomb's law, F equals K Q1 times Q2 over R squared. And the force is given. K is the Coulomb constant, 9 times 10 to the 9th. The two charges here and here, you're going to put those numbers here, and you're going to solve this for R. You ultimately want this to write, R equals some number. And that's probably enough for number 7. 8 is very similar. 2 equal charges of 1 coulomb. Right, so Q1, 1 coulomb, that is a massive charge, and apparently somewhere else there's another charge, 1 coulomb, separated by a distance of 1 kilometer. Now that's 1,000 meters in standard units. What is the magnitude of the force acting between them? So just calculate the force between them. Right, if these are both positively charged, that's going to be a repulsive force. And the force is going to be K Q1, Q2 over R squared. And again, the K is the Coulomb constant, 9 times 10 to the ninth. These two charges are 1 Coulomb and 1 Coulomb. And the R is equal to 1,000 meters. So that should get you through number 8. I hope that this helps. Have a great day.